Hi, hello. Hello. In this video, I will give you a solution about the exercise on antiderivative that I gave you. But remember, I told you that in this exercise, you can have some challenging exercise, which is not really for to prepare the exams. So, but it's also just understand that we can have many other things antiderivative. And in that case, you need just to identify if you are able to apply the approach that we see during the class, during the lecture, to the lecture to see if you can apply them or if you can compute this antiderivative. But first, I need to recall you about the fact that the antiderivative, like you see here, for the function, for example, if I try to find the antiderivative of this, that is equal to 1 divided by n plus 1, x power n plus 1 plus a constant. We also see that the antiderivative of exponential of x is equal to exponential of x plus a constant. And the other side, it is only if I try to find the antiderivative of this one, is to remember the fact that that is because we already have the course is telling you that the antiderivative of f of x dx is equal to capital F of x plus a constant. This means that if I make the derivative of this function, I'm supposed to obtain of f of x. This is equal to ln of absolute value of x plus a constant. But that is in the case that x is not equal to 0. Now, when we have this relation, what you need to remember here, it is about to compute this antiderivative now. But the last case, it is about this one. For this cycle, or trigonometric cycle, you have minus cos of x here, you have cos of x in the side, you have sine of x, and you have in that way minus sine of x. To find the antiderivative of the function, you need just to go back like that. This means that the antiderivative for, go back like this. The antiderivative of cos of x is sine of x, and the antiderivative is sine of x minus cos of x. When you sign this, cos of x dx is equal to sine of x plus a constant. But if you try to find the antiderivative of cos of ax, that is equal to 1 divided by a sine of ax plus a constant. But in the other side, if you wanted to find the antiderivative of sine of x, like I told you, the antiderivative of sine of x is just minus cos. This means that it will be minus 1 divided by a cos of ax plus c. Now, let us go and just give the solution. We can do that really fast. In the first case, you can just see that we have, or we try to find the solution for n equal to 2. N here is equal to 2. Then the antiderivative will be then 1 divided by 3x power 3 plus the antiderivative, of course, we just say that it is sine. We obtain sine of x plus a constant. Now, the antiderivative of exponential we just see here is equal to this one. We have exponential of x plus a constant. And the antiderivative of cos of x, we still exactly in the same position, is equal to sine of x plus a constant. And the antiderivative of 1 divided by x, this is the relation that I gave you here, which is just equal to ln of x plus c. Why ln of x here, not ln of absolute value of x? Just because we already consider that x is positive. This means that we can compute the ln of x all the time. Now, let's go to this one. You can see here, we need just to identify the fact that we have n equal to 3 for the first one, n equal to 1 for the second one, and the next one is just to find the antiderivative for a constant. This means here we obtain 3 times the antiderivative of x power 3 will be then 1 divided by 1 plus 3, which is 4, and x power 1 plus 3, which is also 4, minus 2. The antiderivative of x power 1 will be then 1 divided by 1 plus 1, which is 2, and x divided by x power 2, plus a antiderivative of the constant 4 for x, times x plus constant. And then if I simplify the relation, I just obtain 3 power 4, x power 4 minus x power 2 plus 4x plus c. Now, apply exactly this that I show you here about the antiderivative of this relation. And this antiderivative is just given by 1 divided by minus 1 divided by 2 cos of 2x plus a constant. That is this antiderivative. Now, go to the next one. You can see in this relation that is really different. If we develop this one, this expression is equal to integral of x power 3 minus 2x plus x minus 2. I remember how we make the development of this expression. You just do this time this one, and then this time this one. And the second point, you do this one time this, and then this time this one. Now, this means that we can find, because it's a sum, we can use the sum here. Oh, I didn't explain here, but we already do a lot of exercise in the class when I explain you. When you have this, I can just re-explain for this relation. When you have this is exactly like you have the indefinite integral of x power 3 minus dx minus, because you use the sum and differentiation. And different, yeah, which is equal to integral, and then I will obtain here for 2x that integral of 2x dx minus indefinite integral for this one dx minus indefinite integral 2 dx. And you can put all this one that is x power 3 dx. I can put 2 outside because we use the fact that the antiderivative of for 2x will be equal to minus 2. That is a constant that we can put outside. That is this one minus antiderivative of this. I can put 2 outside, 2 integral of dx. Now the only point is just to find the antiderivative of all this expression. The first one will be then 1 divided by 1 plus 3, which is 4, x power 4. The second one, we already have 2 minus 2, and the antiderivative for x is then 1 divided by 2x power 2 and minus, oh, I think that I have 2x. I will maybe just compute directly. The best way was just to compute directly this expression to make the fact that this one is equal to minus x. That is more simple, but I will just compute directly here. And the second one, the antiderivative will then equal to minus 1 divided by 2. Oh, that was not minus because I keep this, that was plus x power 2. And the last was minus 2 antiderivative of 1 here, which is x plus a constant. This means that the final relation it is 1 over 4 x power 4. Like I told you, this one it is minus 2 plus 1 here. This means that we finally obtain just minus 1 over 2 x power 2 plus minus 2x plus a constant. If you have a question, don't hesitate to ask me to the comment. I will respond to you. Now, we go to this expression. I already explained during the class, but I can still explain here. For this one, you need to think about the new approach for the antiderivative. And this approach for the antiderivative is the fact that, oh, let me see. I was trying to change this, but okay. We just see the fact that the antiderivative, for the case that you have ln of integral of du divided by u, for the antiderivative will be equal to ln of absolute value of this plus a constant. That is coming from the integral of 1 divided by x dx, or let's just say when you have dx here, which is equal to ln of absolute value of x plus c. That is in the case that x is not equal to 0. This also means that u is not equal to 0. If I try to apply the same approach here, what you can observe for the first point that we have for this relation, it is the fact that x power 2 plus 1, the derivative of this one is equal to 2x. In the numerator of this relation, I have x, but I didn't have 2x. If I can decide to say my expression will be then equal to 1 divided by 2 integral of 2x divided by x power 2 plus 1 dx. You see here for this one, this means that I can have directly 2x here. This means I have the derivative of this one, and then I have the function. You can just see that it is exactly like this become 1 over 2 integral of x power 2 plus 1 derivative divided by x power 2 plus 1 then dx. And you can see if I wanted to apply in the case that u here is equal to x power 2 plus 1, you can see that the numerator is exactly derivative of u. We can just apply the same approach that we have here. But still remember, in the case that x is greater than 0, we don't need to apply the ln of absolute value. And you can see x power 2 plus 1 is always greater than 0. It's always positive, and this is equal to ln then absolute value ln of x power 2 plus 1 plus a constant. Okay, let's go to the next one. When we have here, it is the antiderivative of square root of x, and you can write directly like this is exactly the antiderivative of this 1 power 2 dx, because square root is this. And we apply exactly the same approach that we already know, which is equal to 1 divided on 1 plus 1 power 2 x power 1 plus 1 power over 2 plus a constant. And you can see this is exactly 1 divided by 3 over 2 that we have here, x power 3 over 2 plus a constant. And this is exactly equal to 2 over 3 x power 3 over 2 plus a constant. Okay, next step for this relation, we can still apply exactly the same approach to know how to. But my first point, we maybe just chose to say this is equal like integral of x power 4 minus 1 over x power, minus x power minus 2. Yes, dx. We can then separate using the difference for the integration x power 4 dx minus integral f minus 2 dx. This equal to, the first one will be the 1 over 5 x power 5. The second one now, you see n is equal to minus 2. And you remember, this means I will keep minus here, and then we have 1 divided by minus 2 plus 1 x power minus 2 plus 1 plus a constant. This then equal to 1 over 5 x power 5 minus, the denominator will be equal to minus. This means that I can have minus time minus that I have here, that will be plus x power minus 2 plus 1 minus plus a constant. You can then rewrite this like 1 over 5 x power 5 plus 1 over x, because x power minus 1, it is, we can put this x in the denominator plus a constant. Okay, let's go to this case when we have the initial value problem. For this initial value problem that I told you, when you compute the antiderivative, we can see the infinite number of antiderivative. But when you have the initial value problem, this means that you will obtain at the end only one antiderivative. Just to see that, or remember that first, when we write a derivative of y divided by dx is equal to 1, or is equal to x power 3, it is exactly like what we already know. This means that I can find the antiderivative of this one. I will just obtain y of x is equal to then the antiderivative of this, which is 1 over 4 x power 4 plus a constant. Now, we told me with the condition that y of 0 is equal to 5. This means that I can replace y of 0 here. I will then obtain 1 over 4 times 0 power 4 plus a constant, which is equal to 5. This implies that we just obtain the constant equal to 5. Now, when I have a constant, this means that I have my solution. I have the solution to my initial value problem, which is exactly y of x equal to 1 over 4 x power 4, that is x power 4 plus 5. And you can see that we cannot change this antiderivative. We just have this one antiderivative. Okay, let's go to this second initial value problem. The second initial value problem that you have here It is about the fact that you try to find the antiderivative of this one. First, you have the derivative of y divided by x, which is equal to 2 exponential of x minus cos of x. Now, the y of x will be then equal to the antiderivative of this one. We still have 2. We have 2. This is not a problem. And due to the fact that we have 2 here, you can just have directly 2x. Oh, let's say you can have 2 here, the antiderivative of exponential of x, which is still exponential of x, and the antiderivative of this one. Maybe I didn't explain that you can solve this directly, just so you can write this like derivative of y is equal to 2 exponential of x minus cos of x times dx. You can maybe see for the demonstration why I arrived to the expression. And after this step, you just apply the antiderivative. That is why when you apply the antiderivative for this side, you obtain 1 of x. And for this side, you need to find the antiderivative of this difference. That is why for the first one, we obtain 2 exponential. And for the second one, we just find the way that the antiderivative of cos of x is just sine of x. And you don't obtain sine of x here plus a constant. Now we have the condition and we need to use this initial condition to find the solution. To use that, we just use the fact that y of pi is equal to 1 and replace to the expression that we have here. We just have 2 exponential of pi minus sine of pi plus a constant is equal to 1. We know that sine of is equal to 0, and we then obtain just the relation that 2 exponential of pi is equal to plus c is equal to 1. This means that c is then equal to 1 minus 2 exponential of pi. That is the solution that you have here. And when you have these, you need to just go back to your expression and replace to say, oh, finally, the solution of the initial value problem is just y of x equal to 2 exponential of x minus sine of x plus the constant that we have here, 1 minus 2 exponential of pi. Okay, that is the solution for the initial value problem. Now, when you try here to find the antiderivative for this function, you remember that we just have the fact that this one, it is, you can use directly what we have in the courses, but you can also remember that tangent that we have here is also sine of x divided by cos of x dx. And you can see the relation I showed you before to the fact that the antiderivative for integral of derivative of u divided by u is equal to ln of u plus a constant. Okay, I need to go outside for this this box that I make here, but you understand the point. Now, if we wanted to apply this relation that we have here for the solution of the equation that we have in that point, okay, let me see. Okay, I have this means that the solution will be then equal to, here we have sine, which is the derivative of which is not actually the derivative of sine of cos, but because because that is I inverse the relation, this one. Oh yeah, that is okay. So I have to say that is just sine of x divided by cos of x. Yeah, you remember that the derivative of cos, because if you go back to the table that I call you, it was something like that. And the derivative, that is cos here, and the derivative of cos go here. This means that the derivative of cos is minus. You need then to put minus here and then have integral of minus sine of x divided by cos of x. At that moment, you are able to obtain the fact that that is the derivative of cos of x. This means that the antiderivative will be equal to ln of absolute value of cos of x plus a constant. That is the antiderivative that we have here. Now go to the next one. The next function that we have here, that is a little different, because for this function you have the product of two functions. For you have the product of two functions and you try to find the antiderivative of this one dx. But for what I can tell you, for this one, we cannot use the relation that we have until now during the class to proper compute the antiderivative of this function. We can just ask you to use the integration by part. Right? You can use this integration by part. That is b here. Yeah, but due to the fact that we didn't see that for this relation, it can be something that you decide for you to, by curiosity, to go to see what is the integration by part, or how we find this integration by part, to look about this question. It will be the same thing for the next other question, but just remember what you can also have in other side is maybe just we give you the function and try to ask you what is the derivative of this function, or can you fit, for example, if the this function is the antiderivative. Let me show you. I will write little bit something here to say if I can use the integration by part. You don't need to understand this one. It is okay. You can just use the fact that you have u, for example, or you have u is equal to x, and you have exponential of t, which is equal to derivative of v, which is equal to exponential of x, and then derivative of u will be then equal to dx, and the v will be then equal to exponential of x, because we just find the derivative of this one. And now if I replace and use the relation, this one, suppose that we obtain x exponential of x, and in the other side we obtain just exponential of x, so that will be then exponential plus minus exponential of x plus a constant. Okay, that is the way we can ask you this question. We can just ask you to say that is the function f of x, which is equal, for example, x exponential of x minus exponential of x, for example, for plus 5. And we ask you to prove that this function is the antiderivative of this one. At that moment, you see, the approach will be then different, to just ask you to say, compute the derivative of this function. Like, so I use the integration by part, but for the courses, you don't need that until now, or it is not for the part that we see until now. And if we ask you to show here, you need just to make the derivative of this function and say, oh, the derivative of this is equal to x first. You make the derivative of the product, and you still remember the derivative of the product f from g times this one is equal to this is equal to the derivative of f times g plus the derivative of g times f. We then obtain exponential of x for the first one, and then plus the derivative of exponential, and then x exponential of x minus exponential of x plus the derivative of 0 or 5, which is equal to 0. You can simplify this one and you just obtain x exponential of x. That is the way you can have this question now for the courses that we have, or for what we discussed until now. Ln of x is exactly the same. We need to use the antiderivative to find the solution, that is different. And now for this point still be challenging, because for this question we know how to find the antiderivative of this one, and the antiderivative of this is r tangent of x plus a constant, because the derivative, you remember, right? We already see that the derivative of r tangent of x is equal to 1 over x power 2 plus 1. Okay, let's go for this last question. You see, for this one, it is also be challenging, but you need also to do integration by part. And for this case, we'll be do 2 times the integration by part. But still say, you don't need to know how to do this now. Now, for this next step, you can see what we already have to the courses, because you have the you have the table. In the table that you have for your courses, you have exactly the antiderivative of this one. I will just recommend you for the last one to find the antiderivative of this. because you have in the table. Remember this table that I show you. It is exactly for the many other exercise that I have in the previous point. You need to really understand this table and know that you can know how to find the antiderivative or R sign or the antiderivative or cotangent or whatever you have. But for this last point too, you can have see here that I have exactly the kind of same relation that I have before, but this one can be related different, because for this one it's exactly if we ask you to find the antiderivative of u prime and u power n, that will be equal to 1 divided by n plus 1 u power n plus 1 plus c. That is exactly close to what you have at the beginning, integral of this one dx, which is equal to 1 over n plus 1 x power n plus c. And you can see the difference is about the fact that that is x. This means that the moment that we have 1 here is a derivative of this. In this relation, you can see the same point, but that is little different because we need to find the derivative of this. We have exponential, and this exponential means that we have this function u, which is equal to exponential of minus x power 2. If I make the derivative of u, that will be equal to minus 2x exponential minus 2x exponential. But if I just use this relation, this means that it is really more complex. In other side, if you try to find the antiderivative of the exponential, you see that we see exponential of x is equal, dx is equal to exponential of x plus a constant. But that is still also because we have 1 here. This means that if I try to find the exponential of u exponential, u prime exponential of u, du. Oh no, we already have u prime because you can use exactly u prime. This is equal to exponential of u plus a constant. That is exactly what I will apply here, because when I use the relation, you see that this doesn't work. And then I will just use that I have exponential of u, and then u here is then equal to minus x power 2, and the derivative of u will be then equal to minus 2x dx. You see here, I can write my relation using the fact that I will have minus 1 over 2, and then I will just have integral of minus 2x exponential of minus 2x and dx, because I can simplify this minus 2 that I just have, but you see that this product, this one, just give me du. I can have like I have minus 1 over 2, the integral of exponential of u du, which is then equal to minus 1 over 2 exponential of u plus c, which is then equal to minus 1 over 2 exponential of minus x power 2 plus a constant. Yeah, you have this, you have a solution that is different. Now, just for the last one, you still say that is the antiderivative of the polynomial, or for what you are, you can just separate, like we told you before, this exponential of this one, dx minus integral of 3 x power 2 dx. Remember, if we ask you during the exam to really explain each step for your computation, at that moment you need to separate and say, I use the difference or I use sum or difference to separate the expression, and then I also use the fact that I have a constant that I can put outside. But if we didn't ask you to explain each step for your computation, you can just compute directly the antiderivative using the relation that you have here, and then plus 2 integral, let me see, you have this one still inside for the first point. You just have 2 dx. This is then equal to antiderivative of x power 3 dx minus 3 antiderivative of x power 2 dx plus 2 antiderivative of dx. What you understand in that point is that to make this one, you need to say I use the difference, using the difference for integration or for indefinite integral, because you have this property telling you that you can split in the case that you have the indefinite integral for the difference for two function become will be the antiderivative, the indefinite integral for the first one minus the antiderivative for the second one. Now you can just find the antiderivative of this one, which is 1 over 4 x power 4 minus 3. The antiderivative of this one, it is 1 over 3 x power 3 plus 2, and the antiderivative of this one is x. Don't forget the constant. I will continue to recall you the fact that if you